There are more stars in the universe than grains of sand on every beach on Earth. Scientists say hundreds of millions of those stars have planets that could support life. So I need to ask you something. Where is everybody? Welcome to This Explainer. Today, we are diving straight into one of the most terrifying, brain-breaking mysteries of our entire universe, the Fermi Paradox and the Great Silence. Seriously, I want you to really think about that grain of sand comparison for a second. It's almost too big to comprehend, right? We live in an observable universe that is roughly 92 billion light years across, and it's nearly 14 billion years old. Given those massive, just unfathomable numbers, it honestly seems completely impossible that we're sitting here all alone. I mean, mathematically, we shouldn't be. This exact thought actually came up during a totally casual lunch conversation with the physicist Enrico Fermi. He pointed out a glaring, literally universe-sized contradiction. The cosmos is so ancient and so unimaginably huge that if intelligent life is just a natural byproduct of cosmic evolution, well, a technologically advanced civilization should have had more than enough time to spread out and visit every single star system by now. The galaxy should be absolutely loud. It should be buzzing with radio waves, megastructures, starships, the whole shebang. Yet, when we look out into the night sky, we see nothing. We hear nothing. We're greeted only by a creeping, eerie, great silence. And this terrifying contradiction is what we call the Fermi Paradox. So, to figure out exactly how loud the galaxy actually should be, scientists use a sort of conceptual roadmap. It was devised by astronomer Dr. Frank Drake back in 1961. The Drake equation is basically a probabilistic formula that acts like a giant cosmic funnel. You start super broad with the massive rate of star formation in our galaxy. Then, you multiply that by the fraction of those stars that have planets. Then, how many of those planets can support life? How many actually develop life? How many get to intelligent life? And finally, how many of those super smart civilizations develop the technology to release detectable signals out into space? Okay, so you multiply all of those fractions by the average lifespan of such a civilization, and out the very bottom of the funnel you get n. N represents the number of active, communicating civilizations in the Milky Way right now. And here is the absolutely crucial point. Even when scientists plug in incredibly conservative, super pessimistic estimates for all these variables, the sheer mathematical scale of our galaxy insists that n should be greater than 0. The math gives us every reason for optimism. It practically guarantees we're not alone in the dark. And you know what? For a few wild, heart-stopping days in the late 1970s, we really thought the math had been proven right. We thought we heard somebody. On August 15, 1977, a volunteer named Jerry Ekman was reviewing data printed out from Ohio State University's Big Ear radio telescope, and he saw this exact alphanumeric sequence. What's absolutely fascinating about this, which became known as the wow signal, is how perfectly it fit our expectations for alien contact. Eamon was so shocked he literally circled the code in red pen and wrote wow right in the margin. The signal lasted exactly 72 seconds, which happens to be the precise window of time the telescope's sweeping beam could observe a fixed point in the sky. It spiked to 30 times the background noise of deep space. And even crazier, it was transmitting at 1420 megahertz. Now, why does that matter? Because that is the electromagnetic frequency naturally emitted by hydrogen, the most abundant element in the universe. Scientists have long theorized that aliens would use this exact protected spectrum as a universal cosmic greeting channel. It bore every single hallmark of an artificial extraterrestrial broadcast. But then, it just vanished. We pointed way more sensitive telescopes at that exact patch of the constellation Sagittarius. We listened for years. We listened for decades. Nothing. Ever. Again. So, where did they go? If the Drake equation promises a crowded galaxy, and we've been actively listening this whole time, why does the silence persist? To figure out why a civilization might just vanish into thin air, we kind of have to look at how they grow. Enter the Kardashev scale. In 1964, Soviet astronomer Nikolai Kardashev proposed a method to measure a civilization's technological advancement based entirely on its energy consumption. A Type 1 civilization controls all the energy of its home planet. A Type 2 civilization harnesses the entire energy output of its host star, possibly building massive structures like Dyson spheres. And a Type 3 civilization? They command the energy of their entire galaxy. To put things into perspective for us, humanity isn't even on the board yet. We are currently a Type 0 civilization, roughly a Type 0.7 actually. Basically, on a galactic scale, we're still trying to figure out how not to eat dirt. But reaching those higher sci-fi level types might be nearly impossible. There's this terrifying concept proposed to solve the Fermi Paradox, which visualizes an ominous roadblock standing right between the earliest stages of life and that glittering Type 3 galactic empire. It's called the Great Filter. The theory argues that somewhere along the evolutionary timeline, from a tiny single-cell organism to a galaxy-conquering super-civilization, there's a wall, a probability barrier that is so impossibly difficult to pass that almost no one survives it. It's a stage in the evolutionary process that just routinely destroys life before it can ever spread across the stars. Now, there are really only two places this great filter can be: behind us or in front of us. Imagine you're whitewater rafting down a super deadly river. Your guide tells you that 1 million people have tried to raft this river and 999,999 of them died. If you've already crossed the rapids and you're sitting safely on the shore, that's great news. The great filter is in our past. Maybe the leap from single-cell to multi-cell life is the extraordinarily rare fluke, and we just hit the cosmic jackpot. But if you are still in the raft and you haven't heard the rapids yet, it means the waterfall is waiting just around the bend. It means the great filter is in our future. If the filter is ahead of us, it means that technological civilizations invariably discover the means of their own destruction shortly after developing things like radio or spaceflight. The very cleverness required to harness immense power outpaces the wisdom needed to actually survive it. Existential risks like nuclear annihilation, runaway climate change, out-of-control artificial intelligence, or engineered pathogens become the wall. In this scenario, we don't hear anyone in the cosmos because the moment a society gets loud enough to be heard, they blow themselves up.
But the plot thickens. What if civilizations do survive the Great Filter? What if they are out there, they're highly advanced, but they are absolutely terrified? What if they just don't want to be found? This brings us to a much darker, way more paranoid solution to the Fermi Paradox, the dark forest hypothesis. Named after Liu Cixin's incredible science fiction novel, this theory treats the universe as a deadly, high-stakes game of survival. It relies on a concept called cosmic sociology. The rules are pretty simple. Survival is the primary need of any civilization, and resources are finite. To understand the true dread of this theory, consider this quote. "The universe is a dark forest. Every civilization is an armed hunter stalking through the trees like a ghost." In game theory, this is what's called a sequential and incomplete information game. You can literally never know for certain if a newly discovered alien race is peaceful or hostile. Because of the sheer distances and communication delays in space, plus the extreme risk of a technological explosion where a weaker species rapidly outpaces you, the only logical, mathematically sound move upon hearing another civilization is to launch a preemptive strike. To broadcast your location is a death sentence. The universe isn't empty. It's just holding its breath. Now, if we aren't actively being hunted, we might just be actively ignored. The zoo hypothesis suggests that advanced Kardashev civilizations absolutely know we're here, but they're treating Earth like a cosmic nature reserve, observing us secretly without interfering, kind of like how we watch animals in a zoo. Or actually, there is the deeply mind-bending estivation hypothesis. This theory points out that as the universe ages, it cools down. Since computing is massively more efficient in colder temperatures, an ultra-advanced civilization might have decided to simply go to sleep, to estivate, and wait billions of years until the universe is freezing cold, just to maximize their energy use. They are out there. They're just sleeping right through our entire existence. But let's strip away the hunters in the dark forest, the cosmic zookeepers, and the sleeping giants. Let's look at the most sobering possibility of all. What if the Drake equation fractions are simply much, much smaller than we ever imagined? What if the Great Filter is behind us, but it was so unfathomably brutal that out of hundreds of billions of stars, the spark of intelligence only caught fire exactly once? Look up at the night sky. With all its infinite vastness, its ancient history, and its terrifying silence, what if we're the first?